Welcome to Cambridge Chemistry channel with Sarvat Ahmed. Be sure to like the video and subscribe. It really helps the channels to grow. In this video, I will be explaining the factors determine the solubility of ionic solid. Which factors which affect the solubility of ionic solids. You know that when ionic solid is dissolved in water, it undergoes two types of enthalpy change: delta H lattice energy and delta H hydration. Delta H hydration, as you know, the enthalpy change is the lattice energy of the ionic solid but with reverse sign. We know that when delta H ionic solid is formed from its gaseous sign, for example, sodium gaseous sign, when react with chloride gaseous sign, large amount of energy is released. So this is exothermic reaction. Ionic solid, this is exothermic, this is lattice energy. And you know, when ionic solid dissociate into gaseous signs, this is a dissociation of ionic lattice into its gaseous sign. So this reaction is requires lot of energy to decompose sodium chloride into gaseous sign. So this is endothermic process. So that's why the ionic solid, but with reverse sign, that when sodium chloride dissociate, this is positive, but this is equal to the ionic lattice energy. When ionic solid will, because before dissolving, ionic solid first dissociate into sodium gaseous sign and chloride gaseous sign. So that's why it's it is endothermic reaction and its enthalpy change is positive, but it is equal to the lattice energy, and lattice energy is negative, but in this case the ion is reversed. When ionic solid will dissolve in water, it will be positive, yes, because when ionic solid first dissociate into sodium gaseous ion and chloride gaseous ion, this is equal to the lattice energy, but in this case the ionic lattice energy is negative or positive. And afterwards, when dissolve in water, it will convert into aqueous ions, sodium aqueous and chloride aqueous ion. So this is equal to the delta H hydration, which is negative. So delta H hydration, the gaseous ions formed by dissociation of ionic solid now dissolves in excess of water. This is equal to the delta H hydration, and this is sum of sodium gaseous ion and dissociate into sodium aqueous ion, and then chloride gaseous ion into chloride aqueous ion. So this is sum of delta H hydration of sodium ion and delta H hydration, enthalpy change of hydration of chloride ion. Enthalpy change is always exothermic as large amount of heat is evolved in this reaction. These two enthalpies, delta H lattice energy and delta H hydration, are in opposite, and their net effect determines the solubility of the ionic solid. And you know that lattice energy is the energy change when 1 mole of an ionic solid is formed from its gaseous sign. Lattice energy is always negative exothermic, and lattice energy of an ionic solid is determined by the ionic radii of two charges and ionic radii and charge of its ions. Effect of ionic radius. First factor is effect of ionic radius. Lattice energy decreases with increase in ionic radius because it is inversely proportional to the ionic radii. If lattice energy is increased, ionic radius is smaller. If ionic radius is greater, the lattice energy is smaller. Effect of ionic charge. Lattice energy increases with increase in ionic charge as lattice energy is directly proportional to charge of ions Q positive and Q negative. The combined effect of these two factors in the lattice enthalpy of the ionic solid is proportional to the charge over radius. Charge over radius. The combined effect of these two factors in the lattice enthalpy of an ionic solid is proportional to the charge over lattice. Like lattice energy is equal to E is charge and R is radius. E is charge and R is the radius. So increase in charge over radius. This is collectively known as charge density. The combined effect of charge over radius is known as charge density. The increase in charge over radius or charge density of the ions increases the lattice energy of the solid. So what is the effect of lattice energy on solubility of ionic solid? Effect of lattice enthalpy on the solubility of an ionic solid. The ionic solids which have higher, the ionic solid which have higher lattice enthalpy have lower solubility in water. For example, sodium chloride is less in lattice enthalpy than magnesium chloride. Sodium chloride, for example, sodium chloride has less enthalpy than magnesium chloride. So sodium chloride is more soluble than magnesium chloride in water. Similarly, sodium oxide less lattice enthalpy than magnesium oxide, than aluminium oxide. This is across the period, trend across the period. So lattice enthalpy is increased across the period, and when lattice enthalpy is increased across the period, the solubility of the ionic solid is decreased. So it means sodium oxide is more soluble than magnesium oxide, and magnesium oxide is more soluble than aluminum oxide. Aluminum oxide is almost insoluble in water. So because aluminum oxide has higher lattice enthalpy. So if we summarize that, we can say that let's use another color, higher E over R ratio, higher the lattice enthalpy, and lower the solubility. So next, enthalpy of hydration. Which factors determine the enthalpy of hydration of gaseous ion? Factors affecting the enthalpy of hydration of gaseous ions. As you know that delta enthalpy change of hydration is always negative, due to the strong electrostatic force of attraction between opposite ions, between between ions and polar water molecules. So we can say that enthalpy change of hydration of an ion also depends on charge density, which is equal to charge over radius. But in this case, delta A enthalpy change of hydration decreases with increase in ionic radius. And enthalpy change of hydration is decreases with increase in ionic charge. So to sum up, so it means that two factors proportional to charge density E over R. If we sum up this effect, the higher the E over R ratio, higher the hydration, enthalpy change of hydration, and higher the solubility. If we compare with this lattice energy, so in the case of lattice energy, as we have discussed earlier, higher the charge density, higher the lattice energy, lower the solubility. So it means decrease, let's use another color, decrease in enthalpy change of hydration decreases solubility, and decrease in lattice enthalpy change of lattice energy increases the solubility. So this is very important point from the examination point of view. Now I will be discussing the trends in the solubility of sulfate of group 2 and hydroxides of group 2. Sulfates of group 2 and there is a general trend that solubility of group 2 decreases down the group. And we know that lattice energy, lattice enthalpy and lattice enthalpy of hydration both decreases down the group. But as mentioned earlier, these two factors have opposite effect on the solubility. For example, if decrease in lattice energy, lattice enthalpy increases the solubility. Uh, if decrease in lattice enthalpy change of lattice energy increases the solubility and vice versa. Like increase in solubility, increase in delta H lattice energy decreases the solubility. This is vice versa. And next factor, decrease in delta H hydration decreases the solubility and vice versa. Like increase in enthalpy change of hydration increases the solubility. So these two factors affect the solubility of the sulfates, but we can write down according to the examination point of view. There are 2 marks for this question, 3 marks for this question, so we can explain like this. Because enthalpy of hydration of the sulfates of group 2 decreases down the group, therefore their solubility decreases accordingly. Thus, barium sulfate, magnesium sulfate, for example, look at this. Beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, barium sulfate. So these are group 2 sulfates. These two are readily soluble. Calcium sulfate is sparingly soluble, and strontium sulfate and barium sulfate practically insoluble. Practically insoluble. Also insoluble. Practically insoluble. So this is the trend of the solubility of sulfate down the group. So we can explain according to the examination point of view that we can write down like this. The answer of this question, that why solubility decreases down the group, we can summarize like we have to write down answer like this. Both delta H lattice energy and enthalpy change of hydration decreases down the group, but enthalpy change of hydration decreases more than enthalpy change of lattice energy, making sulfate insoluble or less exothermic, or we can say more endothermic. So this is the way to write down the answer when you ask the solubility, why solubility of group 2 sulfates decreases down the group. We can I can I will explain this by using this flow diagram. This is more helpful to understand the solubility of that, how to explain the solubility of ionic solid. Depend on two factor, lattice enthalpy and enthalpy of hydration. Number one factor number 2 factor. Decreases downward down the group. Also decreases down the group. Solubility increases down the group. Solubility decreases down the group. Enthalpy of hydration decreases rapidly than the delta H lattice energy. Decreases less than hydration. So this therefore its effect is not significant and its effect is dominant. Its effect is dominant, hence sulfates of group 2 excuse me decreases down the group. So in this way, how to say that why solubility of sulfate decreases downward. Similarly, solubility of hydroxides, solubility of hydroxides of group 2 increases downward. Or down the group. Like beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Insoluble, insoluble, sparingly soluble, practically soluble. This is also practically soluble. So this is opposite effect if we explain this. That this is also very important question from the examination point of view. This is how to explain this trend. Solubility of group 2 hydroxide. Both enthalpy change of lattice energy and enthalpy change of hydration decreases down the group but enthalpy change of lattice energy decreases more than enthalpy change of hydration, making compound soluble or more exothermic, or you can say less endothermic. So this is how to explain, how to write down the answer of this question, that why solubility of group 2 hydroxide increases down the group. We can also make a flow diagram for this solubility trend. Solubility trend of group 2 hydroxides. First factor delta H lattice energy, second factor delta H enthalpy change of hydration. decreases down the group, also decreases down the group, decreases more, decreases less. So this will become more dominant, less dominant. Hence, solubility of group 2 hydroxides become more soluble down the group. So this is all about the solubility and the factors which affect the solubility of the ionic solids and solubility of sulfate of group 2 sulfate and solubility of group 2 hydroxides.